think I submitted my PA yesterday. I'm pretty sure I nailed most of the parts.
So you're done. Nothing to do. All right, sign-in sheet. Go in the circle, sign your name, please. So I posted an announcement this morning, so I'm going to try something different tomorrow. Tomorrow's class is going to be kind of like an open lab. So I will be here, and if you want to come in and work on PA1 or work on anything else, do some practice programming, whatever, I will be here. You can ask questions, ask me about problems you're having, and I can try to point you in useful directions, things to look at, and so on and so forth. So I will not be taking attendance tomorrow, okay, because if you don't feel like you need to work on anything in here, you don't have to show up, but I'm here. So I won't be taking attendance, I won't be lecturing on any new material, and I also won't be answering emails about PA1 after tomorrow afternoon. So this is your chance to ask questions, okay? So if you're having issues or you're unsure, what should I call the tar file, things like that, right? Figure those things out. My suggestion is either submit your files and be done with PA1 today, right? Or figure out I've got to do more work and then plan on spending class time tomorrow getting some help. And does that make sense? All right. If that turns out to feel like it's a useful thing, if people are taking advantage of that and it seems to be helping people, I may do that as a regular thing once a week, once every 2 weeks, something like that. If nobody shows up or it seems like it's not that useful, then I probably won't do it again. So we'll see how it goes. It's kind of experimental. But hopefully that's useful. I really want everybody to nail PA1. Okay, PA1 is if you haven't done Java before, you haven't done objects before, right? This is where you create your own class that does something meaningful, and you get through all the hurdles of class definition and methods and variables and constructors and so on. And I really want everybody in this course to like finish up the week and say, I know how to do these things, at least to some degree. Even if there's some fuzziness there still, right? We can build on that. In PA2, you don't want to be struggling with, you know, what is a class? I have no idea what an object is. What do you mean when you say method, right? So this is where we can nail those things down. And then we're going to start using those, PA2, PA3, and so on. So I definitely want to be available for that. And you can email me after class tomorrow, but I may not respond. Depends if it's a urgent matter. All right. So let me nip something in the bud and give you an idea on how to do some debugging maybe. So let's say you're trying to develop your GCD method. Okay, this is a function like a C function. It takes two arguments which are integers. It should return the greatest common divisor. You don't have to write this, but if you're writing this hypothetically, right, you would like to be able to test this program, call GCD with some numbers, see what it returns, right? And we haven't really talked about how to write a test program for something like just a plain old function, right? We've really been working in classes. So let me do something. So here's a main class, I'm just calling it main. Here's a main method. And let's suppose that instead of making a GCD function, we're making a function called twice, which is supposed to take an integer and multiply it by 2. Okay, and we want to be able to test this out and debug it and develop it, because I don't want to write a GCD function right now. So here's what I might do is something like this. going to say integer j equals twice I, and then I'm going to print out the values. So there's my debug code. I equals 7, I'll call twice, I'll save the result in j. I hope it's going to say I equals 7 twice I equals 14. And if that works, maybe I'll do another case where I set I equal to -5, and then if that works, I'll say, okay, I'm done. So you could do this with your GCD function if you're making one, or whatever you're doing if you want to make a function. So here's what can happen. Let's make public integer twice, integer argument. And here's the code that I hope will return twice my argument. And this is just a junk main program to test this function. So,
count back.
Yeah. So you try to compile this and you get an error, something like this. And it mentions non-static method cannot be referenced from a static context. Okay, so there's a couple of things that can happen after this. You can start Googling non-static method, static context, and you can start finding advice online. And some of that advice will say something like, put the word static right here. And if you do that, this will suddenly work. And unless you know what putting the word static in there means, you should be really careful. So when I started learning Java, this is what happened to me, right? And I'm like, what the heck is this error message? So I look it up and it's like, oh, it's got to be static. Okay, I make it static. And I make another method, same thing, it's got to be static. You keep making these things static, but you don't know what you're doing, right? At some point, when you start making a class and you start trying to access that class from somewhere else, you start getting a different error message saying, this thing is static, you can't use it here, right? And now you got to take the word static out, but then all of your old error messages come back saying this has got to be static. And now you're really far down this path of confusion and chaos, right? So that's one response to this error message. I don't recommend that response. So here's a different way to deal with this. The problem is this main method has got to be, it's got to have the keyword static. But I'm going to say for now, this is the only place that you should ever have to put the word static in until we actually start talking about statics. So public static void main, perfect. Anywhere else, avoid that keyword, right? If you know what you're doing, you can do what makes sense to you, okay? But if you don't know why you're getting this error message, here's what you can do. We're developing classes in here, so I'm going to make a class. This might be fraction or rectangle or whatever. So put your twice method inside that class.
Is static sort of similar to publics versus privates?
Not really. It has to do, well, let's see, how can I not open a can of worms?
You can table it for now.
Yeah, let me show you how this works, and then I'll make a comment on what static would do instead. So here's our class that we're presumably developing. It's fraction. It's got, you know, add, sub, whatever. Throw your test function in this class. Okay, now from your main method, so what did I call it? My class. So make an instance of your class, and then down here when I want to call twice, call it as a method in that object. So in here, I can write this, I can make recursive call, I can define other methods and so on and so forth. And inside here, if I make another method called, blah, I can just call blah by saying blah. This looks like C code. Okay, we're just writing functions and we can, call functions and so on and so forth. But in the main method, which has this static keyword in there, we can't just call a function that we write here, right? But if we create an object, an instance of my class, we can say that object MC dot and the name of a function, and that'll work fine. All right, so I is 7, twice I is 14. So short version of what a static does, if twice were to be declared to be static, instead of saying MC.twice, I would actually say my class.twice. I'd use the name of the class, not the name of an object. So a static method is one that you call not as part of an object, not as part of an instance, but as a part of the class itself. And we've already encountered statics, for example, when we say math dot square root, right? This is not an object, this is a class. So it's the difference between, do we run this method as part of an object or part of a class? And why we want to do that, why there's a distinction, that's part of the longer discussion that we'll get into later. But the short version is, if you want to test a method, right, make it part of a class and then just say object name dot method. And if you haven't encountered this problem, don't worry about it. All right, any questions about that? Okay, I had vague notions last night at 2 in the morning when I was trying to sleep of making you a checklist for PA1 so you could know that you were done. But I decided not to do that. But I'm going to give you a checklist right now for what you want to do to make sure that you're going to get 100% on PA1. Okay, so so make sure your class is named fraction, uppercase F, no S on the end. Okay. Make sure you can construct with 2 integers, you can construct with 1 integer. You have these 4 methods which return a fraction, not a string. And test these with the test code on the server and make sure that the output matches what it says the output should be. Okay, the 2 double 0.6666, your output will have more decimal points, that's fine. But make sure it's giving the right values. Make sure 2 double returns a double, not a string. And make sure 2 string returns a string, right? And that the output is correct on that test programs. Do whatever you want with reduce. Make sure that if the denominator is 0, the thing is treated as undefined, and anything you do to it results in undefined. Okay, if you divide an undefined number by something, it should still be undefined. All right, so if it matches the output and if it matches a few other test cases, you're up to 85 points out of 100. Okay, and that you can verify by running those test programs and convincing yourself that your code's doing the right thing. So the next 10 points are documentation. Got to have a block of comments in the beginning of your class with your name, CSE 223, the date, programming assignment 1, and then a synopsis of what this class does. Okay, in your own words. Class of fractions lets you add, subtract, multiply, divide, whatever. And then at least a comment at the beginning of each of your methods. So what does the add method do? Well, we can guess it adds something, right? But what does it add? Well, it adds the argument to the fraction. And it reduces into simplest form, maybe, right? So description of the method. Class variables, you probably have a num and a denom. Maybe you have a flag or something. Put a line of comment next to each of those. It's pretty clear that num is the numerator, denom is the denominator, but comment it anyway. Okay. And then throughout your code, anything that's not obvious, put some comments on. If you have a 6-line loop that's finding the greatest common divisor using Euclid's algorithm, I guarantee that is not obvious unless you put comments on. It's obvious to us because we've been talking about it. But just taking this code out of the blue, you're doing a modulo and you're looping until it's 0, and you, right? Throw in some comments. So good commenting, 10 points. Submission details. So make sure your tar file is called pa1.tar, and when you submit, Canvas renames it to submission.zip or your name.zip with a bunch of numbers. That's fine, right? But the thing that you're uploading should be pa1.tar. It should contain fraction.java, no main class, right? Probably just fraction.java, unless for some reason you've got other classes that you're using inside fraction.java. If you are, go ahead and include those. Otherwise, it's just going to have one file. Create the tar file from the directory where fraction.java sits. So there's a way to create it. Don't use packages. Don't include any class files. Right? Don't include anything except fraction.java. Unless it's part of the class. And then upload tar file to Canvas. There's your last 5 points. 100%. So I strongly recommend doing the reverse test. After you upload to Canvas and you think you're done, take another 5 minutes. Go into a new directory on your PC, download what you submitted to Canvas, use your favorite tool to push that over to a new directory on the server, log in, go in that directory, untar it, tar xvf, tar file name, and then copy test program from /temp, compile both of those together, execute the test program, make sure it works. That's going to catch so many possible errors. It's going to catch a corrupt tar file, it's going to catch uploading the wrong file, it's going to catch putting the wrong thing into the tar file, not having the thing named fraction correctly. Right, all these little details. If you can go through that process and run the test program and you get the right output, you know that all those things are solid. Right, but you got to do it in a different directory. Don't just download it to the directory you've been working in, because you might have an old class file sitting there and things like that. So, but that's a good habit in general to sort of double check your submissions. All right, good. Let's talk linked lists. So it's been a few weeks since you've seen me draw this, so yay. So there's a linked list with 3 things in it. It's a linked list of integers, 10, 20, 30. Each one points to the next node. And the last one has a next field of null. So same old test structure that we're used to, same old node structure that we're used to, a data field and the next field. And we want to create a class that will handle linked lists. And can you shoot that sign-in sheet down to that end? So we'd like something like this. Class myList. And we would like to use this something that looks like this in our main program. We'd like to be able to say myList list equals new myList, and have that create an empty linked list. And then we can say something like list.add 20, and that'll insert a 20 into the linked list. And list.delete 35 would find a node with 35 and delete it. Or list.search some number, and it'll return true or false depending on whether it's in there. And the idea is, because we're in an object-oriented realm, once we construct this list, which is a MyList, this one object, this one variable, has all this stuff in it. It's got all these methods for interacting with the list, and it's got the list itself. So if we want to do something with this list, we don't pass it to an add routine, right? The list has an add routine inside it. We just say list.add and the thing we want to add. And if we have a second linked list called list2 and we want to add to that, we say list2.add, and it's totally independent of list. So let's make a simple version of this. And this is going to be simplified because you're going to need to do linked lists for PA2, so I don't want to take away your fun. But let's start a mylist.java. So there's the class description. Well, what do we need to be able to access the elements in this list? Suppose this list exists somewhere in memory. There's a 10, it points to something with a 20, it points to something with a 35, and so on. What do we need in order to be able to get to this list and see that there's a 10, a 20, and a 35?
We need some kind of pointer.
Yeah, we need some way to get to this first node. Now, we can have a Sentinel node. We did that for most of our lists in 222. But with objects, a Sentinel is not as important. And in some cases, it's actually undesirable. So I'm just going to imagine a variable. I'm just going to call it first node. And we'll use the language of points to, even though there's no pointers. But first node basically refers to this first node of the list. And if the list is empty, first node is going to be null. If there's a single node, first node will refer to that node, and that node would refer to null. If there's 3 nodes, first node would refer to this, and so on. Well, these things are some kind of more complex type of variable. Structure in C, a class in 223. So I'm going to call this thing a node. And I'm just going to say first node is a node. This is the first node of the list, or null if the list is empty.
And you can do that?
Do what? Say node, first node?
Yes.
As long as node is a class that exists, which doesn't exist yet, but it will in a minute. All right, let's make a constructor. So this is public MyList. And the only thing we're going to do in our constructor is set first node equal to null. Now I could have just said node first node equals null up in the beginning, and it would do the same thing. And in fact, if I don't give it a value, I think it'll start off as null anyway. But I'm being explicit here because we may want to do other things in the constructor. But ultimately, all we're doing, we're setting first node to null. All right, we want to add a number to the list. Well, I'm going to be lazy. I'm just going to add to the beginning of the list. So when we say add 20, it's just going to put a new node with a value of 20, and it's going to put it right in the beginning of the list. So before we do this, might have something like this. First node points to, I don't know, let's say a 10, which points to a 20, which points to a 30, which is null. And now we're going to say, you know, whatever our list is called, dot add 15. And so after, we want first node to point to a 15, and that'll point to the 10, and so on. So what has to happen to turn this into that? There's, I think, 3 things we got to do. Bless you. So what do we got to do? Do we have a 15? Okay, so we got to make a new node. Which in this case is 15. All right, and then we're going to have first point to that. So first node should point to the 15. And then what else?
Before that, 15 should point to 10.
But 15's got to point to 10. And we got to do that before we change first node, because first node is how we find the 10. So make 15, or this node, point to first node. And then change first node to point to 15. All right, 3 steps should be 3 lines of code. So add something to the beginning of the list. Okay, so make a new node whose data value is whatever num is. Okay, so I'll just call this new node. And we'll create a new node. Sorry, this is just a node. If I call the temp, it would be node temp equals new node. Maybe new node's a bad name, but so that creates a node. That sets the data value equal to num. We should probably create our node class at this point, because we're starting to make some assumptions about what the node class looks like. So here's class node. So integer data, and what type of variable should next be? Is that beautiful or what? So what's next? It's a node.
That's a simple one.
Yeah.
How recursive.
Yes. Alright, so make a new node whose data value is num. So we call the constructor, well, we didn't write a constructor, but there's always a default constructor. And it'll just create the object. And then we set the data value equal to num. We could set the next value equal to null to begin with, but we know we're going to just change the next value in a minute anyway. So 2, have the new node point to the current first node, which is, well, first node is. So new node.next equals first node. And then we got to change first node to point to what's the new first node of the list, which is just this node called new node. So we say first node equals new node. And we're done. So 3 lines to do an add. Of course, we're just adding at the beginning. If you want to add in order, you got to go through and search and back up and all that stuff. Well, that all looks great. Let's write our main method. So create a linked list. And then let's just add some values. So I'll put 4 things into the list. We'd like to be able to look at the list and see what's in there to confirm that this actually worked, right? So how should we do that? Should we write a list.traverse or a list.print?
Or a toString?
Or a toString? What do you think? Should we go with toString? Because if we have a toString, we can just do that. List equals, and we can just say print out the list and throw it between angle brackets for no special reason. And there's the end of our main method, and there's the end of our class. Okay, so I have my aliases set up. So I can compile all of this. I had an extra curly bracket apparently. Oh, I'm missing my curly bracket. Okay, so that's the end of my list. Alright, so compile. And I forgot that the end should be uppercase. So it says mylist.java:8, right? Well, we can count down 8 spots, but if this was deeper in the file, do you know this trick? vi plus 8 mylist.java, and it takes you right to line 8.
No.
So that's a bit of a time saver. So this should be an uppercase N. Let's recompile. That all looks good. Let's go ahead and run it. And it did something, but this is not very satisfying, right? Because we haven't written the toString method. But we know that list is a mylist, and we didn't segfault yet. So that's good. So let's make the toString method. So toString has to be public, has to return a string, has to be called toString and take no args. And we're just going to go through the list, and we're going to take each element and we're just going to concatenate it to a string, so that when we come back and we look at this list as a string, it would be 10 space 20 space 30. And I'm going to have a trailing space because I'm going to be lazy. Alright, well, how do we go through a list and find all the things inside it? We've done this in 222, right? So we start with the first node. We can call this something like temp. We deal with temp's data, and then we set temp equal temp.next, which will point to the next node, and we deal with its data, and we say temp equals temp.next. And we do that until we say temp equals temp.next, temp equals null. And that's when we're done. And if there's nothing in our list, first node is null. When we set temp equal to first node, it's going to be null to begin with. So this suggests we want some kind of loop where we check for the null pointer up in the top. So let's do that. Temp equals first node.
Don't we have to define temp?
We do, thank you. So what kind of thing is temp?
It's a node.
It's a node. So what are we going to do? We're not going to print, right? We're returning a string. So let me do like we did with our stacks the other day. Let's make a string called return value. And let's concatenate the current node's data value followed by a space. And we'll just do that in a loop. And when we're done, we'll just go ahead and return that. And that's our whole toString method. So we construct a list. Let's go ahead and print out the list before we add anything to it. And then let's print it out again after we've added some things. And let's make sure all this works. So we compile this up. Forgot a semicolon. Compile it up, run it. Initial list is empty. I did this in the A section too. So I have a bug. So what's wrong in the toString method? This would cost me 2 points if this was my final exam. Yeah, I didn't change temp. So I just keep looking at the first node and adding that on. So this business of temp equals temp.next got forgotten. Alright, so that should work better. Compile it, run it, there's your list. So initially it's empty and afterwards it's got 4 things in it. Right? This is how we want to interact with objects, with data structures, right? We want to be able to create an object of this type and then just use that to hit the methods. And you know, my stack class could have an add method, my list can have an add method, my tree can have an add method. I don't need to call it tree add, list add, stack add, right? Because if I have a list and I say list.add, it's going to call the add method inside the list class. And if I have a tree and I say tree.add, it's going to call the add method in the tree class. So this is cleaner, this is good code reuse, and this one object list has all that stuff in it. It's got the list itself, it's got all the methods. I can pass it to another method, and now it's got that same access, right? So this is encapsulation, which is a key part of object-oriented methodology. All right, let's talk about information hiding. So suppose I want to give you the option of finding out how long the list is. So return the length of the list. So this is public int length with no arguments. Well, we know we can find the length by starting at the first node and just following it in a while loop and incrementing a counter. That works fine. We've done that before. We could do it recursively. But if your list is a billion things, that's an expensive operation. And we don't need to do that. So we're going to do something sneaky here.
That's easy.
We're going to have a variable called list length. And when we construct we're going to set it equal to 0. And when we add, the last thing we're going to do is increment our list length. And if we had a delete function, assuming it succeeds in deleting, we would just decrement list length. And now my length function is very efficient. Just return the list length. And don't forget your semicolons. All right, so let's actually use this. So we'll print out the list lengths and we'll just call list.length. So we added 4 things, list length is 4. So that's kind of cool. It's a very efficient implementation of length. So you put this package out there and people start using it. And programmers are really good at using tools in all kinds of clever ways. Right? So you may intend something to be used one way, but if using it a different way is useful, somebody will use it a different way. So somebody finds the source code for this, and they come up with the realization, you know what, if I want to zero out my list, I don't have to go through and delete every single node. I figured out a shortcut because I Googled, and Stack Overflow told me I could do this. And there's my sneaky way to delete all the nodes. I'm just going to change that first pointer to be null. So when I'm done, I'm just going to have a list with 2 things. Well, that's cool, and I'm all happy with that. And my final list does, in fact, only have those 2 things. But when I look at the list length, it tells me that it's got 4 things in it. And hey, your piece of garbage list class is broken. Let me write a 20-page Stack Overflow post on why your code is horrible, right? So the problem is we did not expect somebody to come in from outside and manipulate that first node variable. And if we're going to set that to null, we would also like to set the list length to 0. So if we made a zero out the list method, we'd set first node to null, we'd set list length to 0, everything would be great, right? But we want to be the ones who do that. So here's what we do. We make this thing private. And while we're at it, we're going to go ahead and make list length private also, because we definitely don't want people manipulating that. And now when our smart user tries to do this, they're going to get an error and say, you don't have access to first node. And so we're kind of saving the user from themselves. But that's an example of why we want to do this access control on methods and fields. If inadvertent changes to a field could have bad effects, chances are you want it to be private. And in practice, you kind of want everything to be private unless there's an explicit reason why you want the user to be able to access it. And if you want them to be able to read the list length variable, you give them a method for it. If you want them to be able to zero out first node to delete everything in the list, put it in the method and give them access to that public method. And then you get to control how that happens and what else happens at the same time. All right, so there's our linked list. It's a linked list of integers. It's got a list length, it's got an add, it's got a way to convert to a string. So here's the next question. Suppose I want a linked list of strings, which is what we're going to use in PA2. What do I have to change in here to make this a linked list of strings? Just in this file right here.
You would have to change whatever you input into add.
So I have to change how I call this.
And which would also imply a change to node.
And I'll have to change node, but what about in here, this mylist.java file? What's got to change?
You would input a string instead of a number
Where?
during a add method.
Okay. So what exactly am I going to change here?
Public void add string.
Does everybody agree with that? I'm going to change this to be a string. Do I have to change anything else in this file? That's the only change I got to make here.
That's really useful.
That is useful. Now the node which actually holds the data, that's certainly got to be changed as well. But that's pretty much it.
Only 2 edits change
2 edits.
the whole thing.
And so down here when I'm doing my add method, of course I've got to pass strings.
Forgot the end parentheses.
I forgot the end paren and I misspelled this. And I'm going to get rid of this sneaky hack because that'll give me compile errors. So now I'm adding strings to my list. And I run it, and there's my list. Bye, giggle, this is fun, haha, list is 4. And we just implemented a totally new class, right, that makes a linked list of strings. And it was like two words we had to change. 2 spots we had to change the word int to the word string. What if we wanted a linked list of doubles? Same thing. What if we wanted a linked list of rectangles?
This is very reusable.
Yeah. So this is another key idea of object-oriented methodology is code reuse. And this is such a common thing that we're going to eventually learn about something called a generic. And when we write this, instead of saying int or string or rect, we can put in basically a variable. And when you construct a list, you can say, I want a list of rectangles. And you can put rect in angle brackets, and that variable will get replaced with rect. And it'll do what we just did with the editor. It'll basically create the code that gives you a linked list of rectangles, or strings, or linked lists, or stacks, or trees, or anything else. So highly reusable. All right, we are out of time. So, so tomorrow, open lab in here, right? So I'll be around. You can come to either or both session if you want, because I don't expect everybody to show up. So there should be space both in the morning and here. Come by, work on your projects, and then Friday we'll start talking about PA2.